Hello, welcome to Why is Math Like That? The show in which we attempt to explain why some things about math are the way they are. In this episode of Why is Math Like That, I'd like to talk with you about prime numbers, and specifically, why the number 1 is not a prime number. Now, you might remember that a prime number is a number like 5, which doesn't have factors or divisors other than itself and 1. Another way of saying that, if you write 5 as a product of two whole numbers, the only way to do that is 1 times 5. In contrast, you take a number like 6, which is not prime, but composite. If you want to write it as a product of two whole numbers, you can write 6 equals 2 times 3, as well as 6 equals 1 times 6. So 5 is prime, 6 is composite. The first few prime numbers, if you list them, are 2, 3, 5, 7, 11, 13, 17, 19, and so on and so on. You can list these things all day. They go on forever. You never run out. But why is 1 not on the list? It seems, after all, like it follows the rule. If you want to write 1 as a product of two whole numbers, the only way to do it is 1 and itself. Well, let's look a little more carefully at that definition. So we don't actually say within the natural numbers, a prime number is a number with no factors other than itself and 1. What we say is within the natural numbers, a prime number is a number greater than 1 with no factors other than itself and 1. Well, that seems to define the problem out of the room in a way, but it doesn't do much to explain why is it like that. In order to understand what's going on here, let's look at the role that prime numbers play. When it comes to multiplication, prime numbers are the fundamental building blocks of all whole numbers. I like to think of an analogy with chemistry, where compounds have molecules of which the fundamental building blocks are atoms. So let's say you have a couple of hydrogen atoms and an oxygen atom, and these bond together in a molecule. Well, now you have a molecule of the compound that we know as water, with formula H2O. Similarly, if you take a prime number 2, let's have a couple of 2's and a 3, and you multiply those together, we've now formed the composite number that we know as 12 with formula 2 squared times 3. Wonderful. Now, a famous and important property of whole numbers is that this formula or recipe for building a whole number by multiplying primes is unique. Each whole number has a unique prime factorization. So let's say you want the whole number 30. Then to build it with multiplication, you write 2 times 3 times 5. And there's no other set of prime numbers that you can multiply together and get 30. I mean, you can write 5 times 3 times 2, of course, but we know that the order doesn't matter with multiplication anyway. The point is, these are the same ingredients. If you change the ingredients, you get something different. Let's go back to chemistry for a second. We've got a molecule of the compound water, H2O. If you insert another atom into this molecule, let's say another oxygen atom, well, now you have something else. You have H2O2, which is hydrogen peroxide. It's a different compound from water. Definitely not the same thing. Do not drink a glass of it. Do not pour it on your houseplants. Same thing with numbers. If you have the composite number 12, 2 times 2 times 3, and you multiply in another prime number, let's say another 3, now you have a different composite number. You have 36 instead of 12. It has a different prime factorization, not the same thing. So this is the place where you can really see that 1 doesn't act like a prime number. Let's look at 12 with its prime factorization, 2 times 2 times 3. Let's multiply it by 1. If 1 were a prime number, this would be a different prime factorization, and it should give us a different composite number. But no, this is still 12. You can also see it with division. If you take this 12 and divide by one of its actual prime factors, let's say a 2, then that 2 is going to cancel out, and we're going to get a smaller number, namely 6, because we've taken something out of the prime factorization. On the other hand, if we take 12 and divide it by 1, since 1 is not one of the factors in its unique prime factorization, this doesn't take anything out, and we're left with still 12. I think one reason that a lot of people might suspect 1 of being prime is simply that it's not composite. So if it's not prime, then what is it? Well, it turns out there aren't just 2 types of numbers. If we restrict our attention to non-zero numbers, so we'll leave out 0 because it's sort of its own special case, then we actually have 3 types. There are the composite numbers. I've listed the ones as high as 12 here. And there are the prime numbers. And then there are also numbers called units. Now, you don't hear much about units usually unless you start studying some fairly fancy mathematics, because in the context where most of us talk about primes and composites and factorization and multiplication, 1 is the only unit in sight. Well, I guess there's -1 also. If you let the negative numbers in, then negative primes are still prime, negative composites are still composite, and that's great. But if you go into more exotic contexts, you're going to find other units, and we could talk about those all day, but you know what? Let's not. I will mention that these 3 categories of numbers, units, primes, and composites, play well together. We can, for example, set up a times table and see how these types of numbers interact when you multiply them. Units act like the number 1. If you multiply a unit by a unit, you still have a unit. A unit times a prime is still a prime. A unit times a composite is still composite. If you multiply 2 primes together, you get a composite number. And if you multiply a composite number by any whole number, you still have a composite number. This table that we've just set up still holds in those other funny contexts that I mentioned, and in some future video perhaps we will delve into one or more of those. For now, let's summarize what we've just learned about primes and composites and 1, which is neither of those. So we have prime numbers. Here are a few of them. A prime number has a prime factorization that consists of just itself. Then there are composite numbers. You get these by multiplying primes together. I've got a handful here, and see how they're formed out of primes. And each composite number has a prime factorization, which is a recipe or list of the prime numbers that go into it. And finally, down at the bottom, we have our unit, the number 1. 1 goes into all of the prime numbers, which is very different from a prime because the primes do not go into each other. The number 1 has a prime factorization, which is an empty list, a blank slate, an absence of any prime factors. Far from being a prime number, the number 1 is what you're left with when you divide away all the prime numbers on the table, and you can't divide it away. It's a very special number with very special properties, and after watching this video, perhaps now you know a little bit more about why. Thank you for joining me on Why is Math Like That? If you enjoyed this video, please click like and subscribe, and I will have more videos like this coming soon, exploring different questions in math that are things maybe you've heard are true but never found out why. If you remember something that a math teacher once told you was true but didn't give you a satisfactory explanation, leave a note in the comments and maybe I'll make a video about that. After all, mathematics is a subject where you really shouldn't have to take anyone's word for anything, and you shouldn't ever have to be left wondering, why is math like that?